In the vast, seemingly endless expanse of the universe, one of humanity's greatest and most exhilarating quests is the search for extraterrestrial life. The idea that Earth may not be alone in this vast cosmos stirs the imagination and beckons us toward the unknown. Could there be another Earth, just out of our reach, waiting to reveal its secrets? Could it harbor life, perhaps even intelligent beings? A captivating possibility has emerged from a distant star system that has long fascinated astronomers, the Alpha Centauri system. This system, located just over 4 light-years away, holds within it a potential second Earth, a planet that is rocky, slightly larger than our own, and might even have liquid water on its surface. This planet, Proxima b, has become the subject of intense scientific interest and speculation, especially since it lies within the habitable zone of its parent star, Proxima Centauri. The story of Proxima b begins with the discovery of Proxima Centauri itself, which, in many ways, was one of the most groundbreaking astronomical revelations of the 20th century. Before the system's discovery, astronomers had assumed that Alpha Centauri was a single star. In the early 19th century, it was believed that Alpha Centauri was the closest star to the Sun. However, as technology and observational techniques improved, astronomers came to realize that Alpha Centauri was not a solitary star but instead a binary system, 2 stars orbiting one another. These 2 stars, Alpha Centauri A and Alpha Centauri B, were found to be in a relatively tight orbit around a common center of mass, a discovery that significantly changed our understanding of stellar systems. In 1915, Robert Innes, a Scottish astronomer, made another startling revelation: Alpha Centauri had a third companion, which he named Proxima Centauri. This new discovery turned out to be of even greater significance. Proxima Centauri, a red dwarf star, is located just slightly farther from Alpha Centauri A and B than the 2 main stars are from each other. Despite being the faintest of the 3 stars, Proxima Centauri is, in fact, the closest of all stars to our Sun. This discovery reshaped the way scientists viewed nearby star systems and spurred a wave of interest in studying this relatively quiet, faint red dwarf star. Proxima Centauri is an unusual star. Red dwarfs, like Proxima, are much smaller and cooler than our Sun, but they have long lifespans, lasting billions of years. They burn their fuel much more slowly and have a faint, dim light. In fact, Proxima Centauri is about 1/7 the size of the Sun, and its brightness is only about 17% that of our Sun. Despite this dimness, Proxima Centauri remains incredibly interesting because it lies at such a close distance to Earth. The distance between Proxima Centauri and our planet is approximately 4.24 light-years, making it the closest known star to the Sun. Given its proximity, the system is of immense scientific interest, and over the years, astronomers have used increasingly advanced tools to study its properties and investigate whether any planets orbit it. In 2016, astronomers made a sensational discovery that would forever change the way we thought about life beyond Earth. Using the radial velocity method, a team led by Guillaume Anglada-Escude from the Queen Mary University of London announced the discovery of an exoplanet orbiting Proxima Centauri. This planet, which was named Proxima b, orbits the red dwarf star at a distance that places it within the star's habitable zone, the region around a star where conditions might be right for liquid water to exist on a planet's surface. Proxima b has a minimum mass of about 1.27 times that of Earth, and it completes an orbit around its parent star every 11.2 days. Proxima b's location within the habitable zone is what sparked initial excitement. A planet in this zone has the potential to support life, as it could have liquid water on its surface, which is considered a key ingredient for life as we know it. Proxima b is also remarkably close to its star, just 7.5 million kilometers away, which is about 5% of the distance from Earth to the Sun. Despite its proximity to Proxima Centauri, however, scientists have speculated that the planet might still be in the habitable zone because Proxima Centauri is much dimmer than the Sun. The star's faint light could still allow for liquid water to exist on the surface of Proxima b, even though the planet is so close to its star. The idea of an Earth-like planet so close to home, with conditions that could potentially support life, set off a wave of excitement in both the scientific community and the public. the discovery of Proxima b was widely regarded as one of the most significant exoplanet discoveries of the decade. In fact, many scientists began to wonder whether Proxima b could be a mirror image of Earth, a second home for humanity, or perhaps a home for other forms of life that evolved in ways we cannot yet imagine. Could life exist on this distant planet? Could we one day reach it? However, as with many breakthroughs in science, the discovery of Proxima b also came with complications and surprises that tempered the initial excitement. Just months after the planet's discovery, astronomers observed something that cast a shadow over the possibility of life on Proxima b. Proxima Centauri, as a red dwarf star, is known for its frequent and intense bursts of radiation. These stellar outbursts, known as solar flares, can release massive amounts of radiation, which could strip away the atmosphere of any nearby planet. Proxima Centauri's coronal mass ejections are especially powerful, and they have the potential to flood Proxima b with harmful radiation, making it unlikely that the planet could maintain a stable atmosphere. Without an atmosphere, the planet's surface would be exposed to the harsh conditions of space, making it very difficult for life to survive. The frequent stellar flares from Proxima Centauri presented a significant obstacle to the idea that Proxima b could support life. But scientists did not give up hope entirely. Even with the radiation concerns, some researchers argued that it was still possible for Proxima b to harbor life. If the planet has a strong magnetic field or an atmosphere that is thick enough to shield its surface from the worst effects of solar flares, life could still be possible. However, these conditions remain speculative at best. In fact, many scientists believe that the likelihood of life on Proxima b is very low, given the intense radiation and the fact that the planet likely orbits in a way that causes one side to always face its star, leading to extreme temperature differences between the day side and the night side. Proxima b's potential habitability was further complicated by its possible tidal locking. This means that one hemisphere of the planet always faces its star, while the other side remains in perpetual darkness. The side facing the star would likely be extremely hot, while the dark side would be freezing cold. This presents a significant challenge for life, as the extreme temperature variations would make it difficult for life forms to survive. However, some researchers have pointed out that a narrow strip along the boundary between the day side and the night side, known as the terminator zone, could have more temperate conditions. In this region, temperatures might be moderate enough to allow for liquid water to exist, and life might be possible in this small zone. This idea, however, remains speculative and would require further investigation. While the discovery of Proxima b was groundbreaking, it was only the beginning of the intrigue surrounding the Proxima Centauri system. As technology and methods of detection advanced, scientists were able to discover additional planets orbiting Proxima Centauri. In 2020, evidence of a second planet, Proxima c, was reported. This planet is much larger than Proxima b, with a mass estimated to be about 7 times that of Earth. Proxima c orbits farther from its star than Proxima b, and it resides well outside the habitable zone, making it less likely to harbor life. However, the discovery of Proxima c added another layer of complexity to the understanding of the Proxima Centauri system and fueled ongoing speculation about what other planets might exist in the system. The excitement surrounding Proxima b and Proxima c is tempered by a few crucial reminders from the scientific community. While Proxima Centauri is the closest known star system to our own, it is also very different from our Sun in many ways. Proxima Centauri emits much less light, and its radiation environment is far harsher than that of the Sun. These differences mean that the conditions on planets in the Proxima Centauri system could be very different from what we experience on Earth. Scientists have repeatedly cautioned against making assumptions about extraterrestrial life based solely on Earth-like conditions, as life elsewhere could take forms and exist in environments that are radically different from what we know. One of the key points made by astrobiologists is that life on other planets may not follow the same rules that we are familiar with. Earth's extreme environments, deep underground in caves, beneath miles of ice in Antarctica, and in the boiling, toxic waters around volcanic vents, prove that life can thrive in places once thought inhospitable. Could life on Proxima b exist in the extreme conditions of its radiation environment, or might life on Proxima C flourish despite its inhospitable distance from its star? These are questions that scientists are still grappling with, and they point to the fascinating idea that extraterrestrial life could take forms we cannot yet imagine. Despite the challenges in studying Proxima b and other planets in the Proxima Centauri system, there is hope that new technologies will allow us to explore these distant worlds in unprecedented detail. The James Webb Space Telescope, launched in 2021, promises to provide us with the ability to directly observe the atmospheres of exoplanets, including those in the Proxima Centauri system. The data collected from this telescope could help scientists determine whether Proxima b or other planets in the system have atmospheres and whether they might be capable of supporting life. However, this is only the beginning of what could be a long journey of discovery. Looking further into the future, there is even greater hope for sending probes to explore the Proxima Centauri system in person. One of the most ambitious projects currently underway is the Breakthrough Starshot Initiative, which aims to send a fleet of tiny spacecraft, or starships, to Proxima Centauri in just over 4 years. These probes, which would be only a few centimeters in size, would be equipped with light sails and propelled by powerful laser beams. This ambitious project, if successful, could provide us with the first real images of the surface of Proxima b and the other planets in the system. While the technology is still in its infancy, the Breakthrough Starshot project represents an exciting step toward reaching other star systems and answering the fundamental question, are we truly alone in the universe? For now, the Proxima Centauri system remains a tantalizing target for future exploration, and scientists are eagerly awaiting new data and advancements in technology that could finally unlock the secrets of this distant star system. As we continue our quest to understand the universe, the possibility of discovering life beyond Earth grows ever more real. Proxima Centauri, with its fascinating planets and mysterious properties, will undoubtedly remain at the forefront of this exploration for years to come.